You know, when you're trying to measure something and a regular ruler just isn't cutting it, or a single millimeter is still too big? Well, today, we're going to master the tool that solves that exact problem, the Vernier Caliper. Let's dive in. But first, before we even get into the tool itself, we got to understand the problem it was built to solve. And that problem is all about getting truly, ridiculously precise. I mean, think about it. We all have rulers and tape measures, right? They're great for hanging a picture or measuring a piece of wood. But what about when you're engineering something where a fraction of a millimeter could be the difference between success and failure? And that's really the heart of it. A standard steel rule, well, it gets you in the ballpark. Its precision is basically limited by how well you can squint at the lines. But a vernier caliper? Whoa, that takes you to a completely different level. It's the difference between, yeah, that's close enough, and that is perfectly exact. So let's officially meet the hero of our story, the tool that solves this whole precision problem. So what is it? Simply put, a vernier caliper is a high-precision measuring tool. Its whole reason for existing is to measure small things with an accuracy that your ruler could only dream of. We're talking down to 0.02 of a millimeter. That is tiny. And the cool thing is, it's not a one-trick pony. Not at all. You can use it to measure the outside of a rod, the inside of a pipe, how deep a hole is, or even the height of a small step. It's kind of like having 4 different precision tools all rolled into one. Super versatile. Now, to really get comfortable with this thing, we need to understand its anatomy. I know, it might look a little complex at first glance, but trust me, once you know what the key parts are, it all just clicks. First up, we've got the main scale. Just think of this as the backbone of the tool. It's the fixed part that doesn't move, and it looks just like a regular ruler, with all the millimeters and centimeters clearly marked. This gives us our starting point, our main measurement. Okay, now here's where the magic really happens. This is the vernier scale. It's the part that slides back and forth. Its entire job is to give us that extra, super precise fractional reading. This little sliding scale, well, it's the secret sauce to the whole operation. Then you've got the jaws. You'll see 2 sets. The big ones on the bottom, those are your outside jaws for grabbing onto the outside of an object to measure it. And those smaller jaws up top? Yep, you guessed it. Those are for getting inside things like pipes to measure their internal dimension. And finally, check this out. As you slide the jaw open, a thin little rod pokes out from the very end. That's the depth rod. And it does exactly what it sounds like. It lets you measure the depth of a hole or a step. So simple, but so useful. Okay, so we've met all the parts. But how in the world do they work together to get such incredible precision? Well, the secret lies in a concept called the least count. So what is least count? In the simplest terms, it's the absolute smallest measurement that the instrument can accurately see. It's the limit of its precision power, if you will. It's what makes it so special. And this isn't just some abstract idea. We can actually calculate it. The least count is just the tiny, tiny difference between the size of one mark on the main scale and one mark on that sliding vernier scale. It's this clever little mismatch that lets us read between the lines of the main scale. And here's the really ingenious part. On many calipers, if you look really closely, you'll notice that 50 little divisions on the sliding vernier scale line up perfectly with 49 divisions on the main scale. This means each mark on the vernier scale is just a hair smaller than a mark on the main scale. So when you actually do the math on that tiny difference, 1 millimeter minus 49/50ths of a millimeter, you get this number, 0.02 millimeters. That is the least count for a caliper like this. That number is the source of all its precision. All right, enough with the theory. It's great to know how it works, but let's get our hands dirty. How do you actually take a reading? It's really just a simple 3-step process. Okay, it really just boils down to these 3 things. First, you get your main reading, just like with a ruler. Second, you play detective and find the one and only line on the sliding scale that lines up perfectly with a line on the main scale. And third, you do some super simple math. That's it. Let's walk through one right now. Okay, here's our scenario. We've measured something. Our main scale reading, that's the last full millimeter we can see before the 0 on the sliding scale, is 25 millimeters. Got it? Then we look closely along the vernier scale and find that the 6th line is the one that aligns perfectly. And of course, we know our least count is 0.02 millimeters. Now we just have to plug those numbers into our formula. The total reading is going to be our main scale reading plus our matching Vernier line times the least count. So for us, that's 25 plus 6 times 0.02. And boom, that gives us our final answer, 25.12 millimeters. See that? Incredibly precise. And once you get the hang of it, it's actually really straightforward. Okay, so you know how to take a reading now. That's awesome. But let's quickly cover a few pro tips to make sure your measurements are always spot on and you're avoiding some really common mistakes. Now, this is a big one. It's called zero error. Before you measure anything, close the jaws completely. Now look at the two zero marks, the one on the main scale and the one on the Vernier scale. Are they perfectly aligned? If the Vernier zero is a little to the right, that's a positive error. If it's to the left, that's a negative error. You have to check for this first, every single time. And finally, let's just build some good habits right now. 1. Always start with clean jaws. Any little piece of dirt will completely throw off your reading. 2. Double check for that zero error we just talked about. 3. Hold the caliper straight and square to what you're measuring, not at an angle. 4. Be gentle. Don't use a lot of force because that can actually bend the jaws and mess up the reading. And 5. Once your measurement is set, tighten that little lock screw so it doesn't move before you get a chance to read it. And there you have it. You are now officially ready to measure things with a precision of up to 0.02 of a millimeter. Pretty cool, right? But what happens when even that isn't accurate enough? Well, that's when you step into the world of the micrometer. But that, my friends, is a story for another time.